Hey everybody, it's Ms. Haynes for Robotics 1. This week, I guess an announcement first, this week is going to be virtual learning for Monday and Tuesday, February 15th and 16th. So you guys will be doing the bell work and any assignments that are up here, that'll be your attendance. This lecture, it's coming right now, I called it sort of in my mind, Introduction to Pseudocode. And the idea behind pseudocode is it's like when you're writing a paper and you make an outline and then you start to fill it in. That's sort of how I think about it. If you're coding something, you know what you want to happen. You know the basic, sort of the complex behavior you want it to have. You want your robot to, drive forward, turn left, drive forward, turn right, drive forward a certain amount. You want it to follow a maze, or you want it to go over and grab something and pick it up. You have this idea about what you want it to do, but you can't just write that code, drive forward and pick up soda or something. You can't tell it to do that. It doesn't know that. What you need to do is to break it down into these simpler and more basic tasks involved. You need to tell it, what motor to turn on, what power level or what direction to turn the motor on at. You need to tell it how long it has to run the motor. You need to tell it, if there's any sensors, what it's waiting to listen for or to look for, depending on the sensor, or sensing, like a pressure sensor. When this pressure sensor is push, then stop. That sort of thing. So the process is sort of thinking about the algorithm. You have to tell it to do what you want it to do. And it sort of harkens back to when we made those sandwiches and you had to write instructions out, and the more vague your instructions were, like for a human, if I say, hey, make a sandwich, you kind of know what's involved. You're going to get out a plate, you're going to get out bread, you might ask, hey, what do you want on the sandwich? And then you start putting the ingredients on, you put the condiments on, put it together, you've got a sandwich. But a robot is not going to know what you mean by make me a sandwich unless you've told it and programmed it already what to do. You're going to have to tell it the sort of order of things, the simpler tasks involved. You're going to have to tell it what to do to get the bread, put it on the plate. You have to tell it where to get the plate. You have to tell it how to do all this stuff. And for each of those simple tasks, you're going to need to tell it what motor to move, what direction, how far, how much. If I need to extend an arm for something, I need to tell it to run the motor that controls the arm extension this much until it's this far, or until it senses something, and then run the motor that closes the claw, this much until it senses that it's got it. And then you have to tell it line by line what to do, or it will not do what you want it to do. It won't understand. It will do something wrong, perhaps. So what we're going to do is we're going to talk about how you break down something that seems like maybe a simple task but more complex into simple tasks, and then into a basic task. So the thing that I've got for you guys, this is loaded up. This is the Introduction to Pseudocode sort of worksheet that I've been doing in class. So some of you, if you're a traditional student, you've already done this. That's great. If you finish this lecture up, you want to go on to the next thing we do, that's also great. So for those of you who haven't seen the lecture, though, who haven't been in class, I've got this sort of 3-column worksheet here, and then there's some more stuff to do below here. But let's fill this in first on our own. So it says complete the chart below by writing the basic, simple, complex behaviors for this mobile robot's actions. And this is what it tells you about the mobile robots. When a button is pressed, a mobile robot will go as fast as possible for 20 feet, which takes 10 seconds, and then stop. So when I see that's pretty much a complex behavior. Let's just copy paste that in here. That's exactly what it is. I don't need the tab though. There we go. Maybe make it a little bit larger. Well, it doesn't matter. You guys are seeing this on the screen. You can make it larger. It's not like it's up on the board. We can't see it, but I'll make it a bit bigger. That's what you want it to do. All right. That seems simple enough, but really you've got to figure out what instructions in what exact order does this thing need to follow. So let's break it down to some simple steps. All right. This thing is going to need to sense when the button is pushed. That's got to happen. This thing is going to need to go as fast as possible. It's going to have to go for 20 feet at that speed. And then you need to stop. So you're going to have to sense the button. You have to go for a certain distance, and then you stop. Those are the things that you've got to do. So when you're talking to a robot, what kinds of things do you need to actually tell it? Well, You need to have a line of code that says, when sense when the button's pushed. So you need to have this again, sense when the button's pushed. That is pretty basic as is. How do you go as fast as possible? You're gonna need to turn the motor on. You're gonna need to turn it on at full speed. That'll make it go as fast as it possibly can. Go 20 feet. How do I tell it to go 20 feet? Unless it has some sort of potentiometer sensor that you can do some math and figure out the radius or diameter of your tires, circumference, how many rotations it can go before it goes 20 feet total, you're going to have to use some other method. And so a lot of the time what you're going to use in these scenarios is time, literally time. So 10 seconds. You need to wait for 10 seconds. So I turn my motor on. I'm going to wait 2, 3, 4, 5, 6, 7, 8. I mean, I'm counting a bit fast, but 10 seconds. It will have an internal timer. And then the last thing it'll do, well, turn the motor off. That's it. Those are the line items you're going to have. And what it's going to look like when you get to coding is each one of those basic behaviors. Once you get this far on, we will be able to sort of know. Hopefully y'all can read that. You'll be able to know what piece of code will make it sense the button being pushed. What piece of code needs to turn the motor on? What piece of code tells it to wait? What piece of code turns the motor off? And all programming languages are kind of like this. Some of them have different ways that you call upon these functions, but they will always have this sort of, okay, I gotta tell the motor to turn on. Okay, I gotta tell it to wait. Okay, I gotta tell it to turn off. Okay, now I gotta tell it to wait again. I had to tell it to turn this light on. I had to tell it to turn this light off. I need to tell it to turn, well, that wouldn't work. Turn the light on, wait, turn the light off. You'd need to tell it all these little steps. And all together, all that code will make your robot do what you want to do. All right. In class, I had folks finish filling in the bottom two here. The bottom two questions is list 5 smaller behaviors you could break the complex behavior brushing my teeth into. So think about the steps you do when you brush your teeth and tell me 5 of them. It doesn't have to be in order. It doesn't have to even be all the steps you take. Just tell me 5 of them or more, at least 5. And then tell me why you think it's important to think of a computer program as a set of basic, simple, or complex behaviors that a robot needs to follow. All right. If you don't have a printer or can't print this paper off and fill it in yourself, just take notes on a piece of regular paper. And I will put these 2 questions in a quiz in this assignment. So when you're through watching the video, go check the assignment, click on the link to the quiz, and I know it says quiz, but it's kind of open-ended. And I'll have to look over it later, just like I would look over a piece of paper. Alrighty? Let me know if you have any questions, and y'all stay warm, stay safe. Hopefully all y'all's power stays on. You don't have problems like that. Yeah, I'll see you later.